Figure 1.2 shows a vertical speed time graph for a parachutist who jumps from a stationary hot air balloon. The parachutist jumps from the balloon at time 0 seconds and reaches the ground at B. The point A indicates when parachute opens. Explain in terms of forces the change in motion which occur from when parachutist leaves the hot air balloon until point A. Let's say this is Skydiver. There are two forces acting on Skydiver. One is weight, which is force of gravity due to the gravity pulling the Skydiver downward towards the earth. This force acts downward and this is constant throughout the fall. And another force is the air resistance, which acts in opposite direction to the motion. Let's write two forces acting on Skydiver: weight and air resistance. When a skydiver first jumps from the aircraft, they experience only the gravitational force because air resistance is negligible at first here. So the net force is primarily downward and the skydiver accelerates downward. As skydiver accelerates downward, what happens? The air resistance increases. Until here air resistance increases until skydiver stops accelerating. When it happens, this air resistance balances the gravitational force, increases until it balances. Let's write weight, gravitational force. Guys, here, do you see speed is constant? Here, air resistance and weight are balanced. It means that they are equal to each other. So what happens in this case? In this case, the resultant force becomes zero. Why? Do you see here we have two forces acting in opposite directions? So the resultant force or net force is equal to weight minus air resistance. When weight and air resistance are balanced, resultant force becomes zero and the skydiver stops accelerating, falling at constant speed. And the skydiver reaches terminal velocity.